In this first video, we'll consider the twin factors of energy and force. And even though this is a chemistry course, there are a few things about physics that we need to keep in mind as we go through our study of matter. First of all, we're not just going to study matter, we're going to study matter in the context of energy. And energy is really the thing that causes matter to change, and sometimes the very effective matter changing generates energy. So what is matter and how is it composed? This is something that's usually addressed at the beginning of a physics course, and matter is anything that has mass and takes up space. What is energy? Okay, this is the topic of this video, but what energy is basically a property of matter, and we find that the energy of the universe is typically conserved, but Einstein, back about 100 years ago, also determined that energy and matter could be interconverted, and this is the energy that comes from a nuclear explosion, for example. What do they have to do with one another? Well, as we've already seen, as I've already said, matter and energy can be interconverted. It turns out that whenever matter changes, it usually is accompanied by some kind of energy change. So chemistry, what we'll be studying throughout the rest of the semester, is a study of matter and energy. Now I want to make some things clear about energy and changes. We're going to be looking at energy changes from the perspective of the system. Now the system in this case is typically a molecule or some kind of collection of atoms that we are particularly interested in. There are a couple of conventions that I want to make sure we have straight. First of all, if energy flows into the system is adding energy, so we consider that change to be a positive change in energy. Energy has come from the surroundings, the rest of the universe, and it has gone into the system. So whenever you see energy is greater than zero, you can assume that energy was added to the system. We might also draw that as a diagram where we use energy as the vertical axis. And in this case, we might start at a lower energy, and the transition that takes place during some change in the matter actually adds energy to it. So these two lines are showing, the two black lines, are showing levels of energy that the system might have at the beginning, the lower left, and at the end, the upper right of some process. So it's pretty easy to figure out what happens if energy leaves a system. In this case, energy is lost, and so we define that energy to be negative. And again, we might draw a diagram with energy as a vertical axis that looks something like this, where we start at a higher energy and we go to a low energy. So these are the kinds of pictures that we're going to be seeing quite a bit through this course, and I hope you'll get comfortable with seeing these things and understanding what they mean about changes in energy. Now, it's also important to realize that the energy units are called joules. And they are, in the metric system, they're defined as kilograms times meters squared divided by seconds squared. All right, so if you can at least bear that in mind, it'll help you to, I think, piece together some of the things that are changing when we look later on at chemical reactions and those sorts of things. Now, the other side of this is force, and one of the things that I think a lot of students get confused about is force is not the same as energy. We talk about force a lot. We sometimes talk about it as though it is like energy, but it's not. And one way we can see this is that the units of force, these are called newtons after Isaac Newton, are kilogram meters per second squared. Notice that it's not meters squared. That would be a joule. So in this case, we can define energy as the force that is exerted over a distance. And so we might then say that 1 joule is equal to 1 newton exerted over a space of 1 meter. And indeed, when we multiply the definition for newtons up above by meters, we get the units of energy, or joules. Now, when two things are attracted to each other, attractive force brings them together, we define that force to be less than zero. So you can think of the sign of the force as telling you how the distance changes between two particles that are feeling that kind of force. Similarly, if we have a repulsive force, we have two atoms that are being pushed apart, or two particles that are being pushed apart, and in that case the force is going to be defined as a positive force or a positive quantity. So I hope these few definitions are things that you can take to heart. We'll be using these throughout the course, and so it's good for you to get straight in your mind the difference between force and energy so that we can begin to use them as we further study chemistry.